today's discussion, I'm hitting on two disparate topics. Both of them are joined by the aspiration, hope, that the material will be of substantive, almost daily assistance to you in a career or in your work. Maybe day-to-day is a little bit much, but maybe at least week to week, maybe multiple days within a week. So the two topics are the use of sed, the so-called stream editor in Unix, specifically for the purpose of substituting one regular expression for another. Sed can do lots of things, but a lot of the things that it can do are rarely exercised these days. What sed excels at is replacing one regular expression by a substitute, which happens to be encoded as in some cases using elements from regular expressions. So we're going to see how you can use sed to do essentially find and replace in the text of files. This is a need that I have an awful lot. I don't know about you folks, but I work with a lot of larger text files. Sometimes they're not text, sometimes they're Word files or what have you. And I want to do systematic replacements in that file. And it is tedious to have to specify only in terms of those file replacements, only in terms of actual text, like replace precisely this text by something else, replace this slight variant of it by this other thing. Instead, it's nice to have a single expression that matches all of those things and have a sort of rule for, well, given that expression, how do you replace them? Okay. How do you replace them all at once? So we're going to be talking about sed for that use without aspiring to cover all the details. And then we're going to be going on talking about debugging. Again, one of those things that if you can get really skilled at it, can speed up your development and productivity very quickly. Okay. Those announcements are outdated. Ignore that announcement. Okay, that's a non-announcement. Inverted. Okay. So we're called regular expressions. We've seen regular expressions before. And I'm coming back to good news. Regular expressions, ladies and gentlemen, are your friend. They will, and even if you don't feel that way, they're going to be your friend for a long time. They're going to be accompanying you through your classes here. They're going to be accompanying you through your professional life. And look, if you're going to have a family member who's going to accompany you through life, you might as well be on really good terms with them, right? And I know, like family members, it can take some getting used to their quirks and idiosyncrasies, maybe even neuroses, but it'll behoove you to sort of come to understand them, come to appreciate them for all their strengths and limitations, know on what things you can rely on, and then on what things you have to look elsewhere. And regular expressions are just like that. And if you can come to sort of understand their strengths and limitations, it will let you put them to use in just cases where they're needed, and for you to rely on other friends for other cases. Okay? So we talked about regular expressions, and it turns out regular expressions are super useful practically, but there's deep reasons for their usefulness that you'll probably come to in higher level courses on theory of computation. They can allow us to capture a certain level and express a certain level of computation in a very succinct, but also very universal way. Okay, so we saw grep before, and although I had sort of alluded to the fact that muttered things about other tools supporting regular expression, your experience of regular expressions was largely defined in terms of grep. Grep for this, grep for that, and that's great. Grep is one of the most useful tools out there. And it has different variants, and it can be mixed and matched with other tools like find, and it's fantastic stuff. But grep lets you find these things. It's a pattern matcher, but it doesn't let you, once you found it, it doesn't let you replace it by something directly. Often that's a need. So when we have a text editor, we have Word, or whatever program, typically there's a find, and there's a find and replace, for if it allows you to build up the problem. So many tools use regular expression you're working with larger text files, which is very common in the Unix space, very common in many other areas of discourse, having an ability to kind of replace X by Y throughout a file is really, really useful. So there's this tool in Unix called set, and the name denotes stream edit. Okay. And basically the task at which it excels, the task for which it's designed, purpose-built, is textual manipulation. Unix has a deep philosophy, and by the way, this is something that's potentially I might ask. Unix has a deep philosophy of providing, putting less emphasis on providing integrated systems to do, broad sets of tasks at once, the sort of IDEs type situation. And more, it puts its emphasis into small tools that can be composed together in flexible ways. So you have the word counts, you have the greps, you have the finds, you have the capacity to, do tools like diff and compare, and these are individually quite powerful, but it's really when you string them together with things like pipelines and command chaining, as we'll see, or a form of syntax where it takes the output from one, makes it the arguments to the other. That's when you start to get real creativity. You can pipe one into the other, do redirections, use T, and combine them in really clever ways, in ways that are unique for your context. And then you can build up shell scripts which sort of regularize those and extract them, encapsulate them. Sed is one of the most useful of these sort of tools. It doesn't aspire to do everything. It doesn't send mail. It doesn't check your Facebook account. It doesn't go and manipulate the network or something. What it does is it manipulates text strings. Okay. Now, it turns out that it has huge capacity to manipulate text. You can do all sorts of amazing things with that. But these days, a lot of its full power is under-tapped because we have other resources to our avail. We can easily write a Perl program, or we can write a Python program, or a Scala program that does these things quite readily and in a nicer syntax, a nicer way. But sed just, I can express it, but it's hard to overexpress it without using improper language. So it's amazing at certain tasks, okay? And the task at which it absolutely excels is replacement of one expression by another, okay? Where those are regular expressions. Here, the idea is we're going to cover specifically here, not sed as a whole, but specifically the use of sed for doing replacements, okay? And that's what I've asked you to do in your lab. If you go to the textbook, you can recognize that, wow, there's all these other things. And some of them are pretty useful. Like there's one that replaces this. It allows you to map this character to that character, this other character, A to Z, and, B to Y, C to X, or what have you, very nicely mapping them, and in a very succinct, crisp way. And you can read about a lot of other strengths to it in the Sobel book. And that's great if you'd like to learn more. But what we're going to be talking about specifically is the use for replacement. And as such, we're only going to use one command, set. And you might think, well, it's kind of like, you taught us Python and all you taught was a plus operator. Well, sort of. There's a reason. We have limited time, but more to the point, this is where sed is amazing and where it has a dominant position. Like if you're looking for a tool, my first choice would be sed to do this, okay, above any other tool for textual replacement in the family. I'll do it. Any other tool, I can use awk, I could go and do a little Perl script, but it's just so crisp, so sweet, that's the tool of choice for many people. Okay, so the idea here is that sed allows you to provide a script, and that script can either be provided on the command line directly. You could do something like sed, and then putting this in quotes, you know, I'm going to replace heavy some character between them with a question mark, heavy weight. So this character might or might not occur between them by heavyweight or something like that, all one word. And I'll do so even if there's more than one occurrence of it, and I'll do it with -r, meaning that I'm using extended RegExpression syntax in the form of this question mark. And what this is going to do is it's going to say, well, if you see this string heavyweight, but possibly with a single character between, like a dash, for example, or a space, and I can list those out if I wanted to, replace it by this single thing. So this is in quotes here, and this is a command line definition, use of set. Okay? So it's canonicalizing. It's making consistent my use of this term to make sure I put it all in one word, or put I can put a dash here. So it's all on that. This is an example of set purely from the command line, but the script is on the command line. Another option is I could specify a script which is available in a file. Sed -f some file.sed, and that's another command. Now, regardless of whether I place it in quotes or whether I put it pointing to a file here, conceptually what I have in this set of commands I'm giving is a script. We call it a script. It's a sed script. And each line of that sed script, folks, provides a different command. So this file.sed might have several different lines within it, and they each get executed in turn in a pipeline sort of fashion. I've just thrown in some terminology that will probably be unfamiliar for the people passing the hall. Pipeline. What do we mean by pipeline fashion? Yeah, so this is a recurrent technique you'll see in other areas of computer science, most notably next term with 215, but you'll see it quite possibly in later classes, and well, you'll see it in some of my classes down the road if I'm teaching them that in the year. And the idea here is that we have each successive line within the file will provide one command. Maybe, since we're focusing on the S command, substitute. That's what this S means. Each one will consist of various substitutes. And we're going to have a set of lines coming in from a file so this sed command is just waiting for standard input. So we could give it, a input from foo.txt, and each successive line of foo.txt will be passed through each of these lines in turn, successively. So first it'll be passed through the first line, which will perform some substitution. Then it'll be passed through the second line. We pass through the third line. Now the reason I say pipeline, though, is not merely that it's passed in turn in this way, but when this second line is working on, the second line of the script is working on the first line of foo.txt, this first line of the script could be working on the second line of that. So maybe the first line of foo.txt is some command that starts with some words that start with A, and the second line is words that start with B. Sure, we'll say that. It's a bunch of words. So this guy here, first A is processed by this command, right? And it maps some text in here to some other text. and these guys are still awaiting input. And then next, that first line goes on and starts being processed by the second line of the file. Meanwhile, this guy can start processing the second line here. And following that, we have this first line is now being handled by this third line of the script. This is the file.sed.script, to be very clear here. And the second line of this file is being handled by the second line of the script, and the third line of this file is being treated by this first line. So each of these lines from this file here, foo.txt, is passed successively through each of these different commands. But conceptually, we can think of it as processing them in parallel. Each one of these lines is working on a single line of this file at a time, but they're all kind of going through from top to bottom. So the upshot of this is that every line of foo.txt is going to go through is going to be processed by each line of the sed script in turn. Here, there's just a single line of the sed script. So we're going to process through that code. Done. And you're going to get a set of lines that come out of it. By contrast, if we have a sed script that has many different lines in it, they're going to be executed one by one each, depending on the output from the previous one. So, is that clear to people? People comfortable with that? Okay. This notion of pipelining may be unfamiliar, but you'll see it sort of recurrently coming up because it's one of the ways that we can allow parallelism to be going on. We talked about it earlier in the context of pipeline instructions. Right? We talked about, so when we were talking about pipelines, we say command A is piped to command B, and we feed in, if we were to say cat foo.txt here, and we feed it to A, then A could be working, first works on the first line of this, it passes that to B, and now it can be working on the second line, while this guy's working on the first line successfully. Remember that? Okay, it's the same basic idea here. We have sort of each of these lines of this sed script. But each line just does something very simple. It says, place this button. Place this button. And ladies and gentlemen, that file that you'll be creating this afternoon will consist of a series of lines. Each says, replace this button. And conceptually, each of those lines should be quite simple. It should do a specific thing. This line replaces all commas by hashs. Like this. This line eliminates extra spaces at the beginning of the field. This line cleans up, extra spaces in the middle of a postal code and replaces them by mistakes. Each of those should be a purpose-built line that does one thing. That's the idea. So you have a sed script, and conceptually it's quite a sophisticated mapping that's going on, but you decompose it, you divide it, you have a divide and conquer. Each part, each line of that sed script does a particular thing. Does that make sense? Okay, so let's look at what these sort of lines look like. So each line is of this sort. We're only using the substitute command here, folks. There's all these other commands, print commands, map character commands with Y, etc. We're just doing that, okay? That's all we're doing. That's all you're responsible for. It's the only thing for which you're responsible. Okay. So here we have S/, and the slash is just a delimiter here. What do we mean by delimiter? Anyone? Separator? Yeah, it's a separator. It indicates, it denotes a separation between successive fields. So it's a way to easily recognize what's one of the fields. And specifically here, there's three fields of importance. Number one, what's the pattern you want to match? What's the thing you want to replace? Conceptually? That's thing one. Thing two is, with what do you want to replace it? to substitute for that if I could use the type of English reference we're on. What? We've already done a lot of getting rid of that. Sorry, I should really do breadth of search on my depth first. Okay, so flag is the final thing. And flag is just one of a small number of things that tells, sort of gives different variants. It's kind of like an option to do it only only replace the first one, or replace it as many times as needed, like in a given line. So most common flag there is you do G, meaning, hey, don't just stop at the first one. If I see a line where it says heavy weight, twice in it, replace both of them. So you have /G at the end. See, there's G here. That's the flag. We call that a flag. Okay, so the replacements here things that we're replacing for the pattern commonly include text. They may include the full pattern matched, the full pattern matched by the pattern given in the first element. But perhaps, so text and this last one is the most common. \and. In other words, \1, \2, \3. Can anyone tell me from where we've seen this syntax before with regular expressions, \number, what does that represent? Yeah, so it remembers the nth grouped map. So it allows us within the RegExp To Match to group things together in this sort of syntax. This is the extended regular expression syntax that you get with sed -r. I'd suggest that you use that for today's lab. Do use it. It will clean up your regular expressions. You don't have to put \begin paren, just put begin paren. Okay. So if we have a expression as part of a bigger regular expression like this, the thing inside the quotes, what does that parentheses accomplish? Why do we have a parentheses there? There's two reasons we can have parentheses. So two motivations.
Stores the value?
Yeah, it stores the value. And that's probably the most important reason. The second reason is it allows us to kind of refer to it as a unit, so we might have a question mark after it, and it says this whole thing occurs or it doesn't occur. It's kind of like parentheses when we're evaluating mathematical expressions. You say, we want the times operator to apply to A plus B as a quantity. So you put A, B, parentheses, right? A plus B, parentheses, times C. We want the C to, the times operator to apply C to the entire thing. And that is the sum of them. Here, we might put a question mark after to make it apply to all of it, but in this case, what our real interest is in giving it a name, having it be remembered. And the way we give it a name is we refer to it as \1 if it's the first such grouping expression. First such thing with these parentheses, \2, it's the second, \3. Are people comfortable with that? So that's going to be a key part of how you answer your lab for a few of the things. And it's going to be a key part potentially in the final exam questions involving set. Are people comfortable with that sort of notion? So ladies and gentlemen, if I had right. So if I wanted to match a postal code and be able to refer to the first half and the second half, how could I do it? Tell me how to build this up from scratch. Postal code, Canadian postal code. Okay, so a capital letter, how can I denote that in a regular expression? Sorry? Okay, so should I just put this? Square brackets, thank you. Good. Is that all? Okay, so let's suppose I want to do this in the most sort of, using only the simplest operators. I know we can put, you know, curly brackets, and we get 3 of them and so on, but let's do it the most simple way. So then, okay, so, sorry, 0 to 9. 0 to 9, and then A through Z, right? Okay, that's great. And then how about, okay, space. So suppose that I'm using extended regular expression syntax so I can refer to space as \s. How many of these? Okay, a single space, I might say, if it's to be a fully legal. And then I could have this whole thing again, right? Through A through Z. Asking you, this may seem basic for some people, but asking this helps me make sure that you folks are remembering things. Okay, it also rehearses something. So suppose now I wanted to remember it. Suppose I only want to include the first 3 digits of the postal code. So some of the health work I do, we're only allowed to sort of look at that information for privacy reasons. So how would I replace this regular expression? I'm leaving some space in it for some extra characters by only the first thing that was the first half of it. How would I do that? Sorry? Oh yeah, you're right. S7H3B4. Yeah, thank you. Thank you. So I stand corrected. I'm glad that that isn't going to be on my citizenship test. So I got back a letter from, so I'm not kidding, it's actually a little bit. So I got back a letter from Citizenship Canada for a citizenship application. It's actually an extremely painful form because you have to enter every single time that I've been out of the country. I travel out of the country quite a bit for giving talks and professional meetings, etc. You have to list every time the past 5 years I've been out of the country. And it doesn't remember it, so you have to enter it and say submit, and after that, if you have to go back and change it, you have to re-enter it. The exact dates, you know, and so we did that, and then I got back a letter saying that I provided insufficient proof of my language capabilities. So if anyone wants to write in Citizenship and Immigration Canada and suggest that my language deficiencies are limited in their scope, I would welcome a character reference. Okay, but evidently I failed the postal code. S783B4. Okay. Great. S7N5C9. Great. You would think that would have sunk in. Okay, so if I want to replace that by only the first thing matched, the first half of it, how would I do that? Okay, so parentheses around the first half, and then what do I put here? \1, and then I can do a G in case it occurs multiple times. By the way, if I want to do it as a case-insensitive match, if I'm not mistaken, you can double check this in the said manual, but I think it's GI. So it's case-insensitive match. Okay, in other words, it'll match even if it's lowercase. It'll say, okay, I know what it is. Now, for robustness, you might allow the fact that some people might have forgotten to put the space, or might have put more than one space. So you might turn this into \s plus, or you might even do SAR to allow the fact that some people write it without a space sometimes. But sure. Any of those. So here we can replace this \1 refers back to this guy because it's the first one. How if I wanted to replace it by the second one? Well, if I wanted to use this other one as well, I could put a thing here and I could do \2. Then it would be the second sort of root thing here. Okay. So if I have in a single replacement string, I have multiple cases where I use these parens, I refer back to them by sort of the occurrence of the opening paren. Okay, first one, if I have nested one, which I can have, then that would be x up 2 here. Okay, if I have multiple nested ones, and here I can still refer to just bearing in mind what first the opening is for. Okay, people comfortable with that, because this will be key. It'll be key for flat, it'll be key for your use of these in general, as said, okay, good. So I mentioned some flags here, case insensitive and global flag being the most notable ones. The print flag can be useful if you're using sed more broadly, but you don't really need to know about it. Okay, so here's some examples. Here we're going to be mapping, for example, month, day, year, stated in that form, which is conceptually a bit abusive in the sense that we go from a coarser category month to a finer category day, and then back up to a really coarse category year. Suppose we wanted to map this into year, month, day, which is kind of a more consistent feel, coarser and finer in general. Well, we can do so with this sort of expression. Here we've used these matching for digits. I haven't tapped into the ability to match digits in some special way. Instead, I'm just using it in the way to be most obvious to you. Why do I have this backslash, forward slash kind of there? Yeah, so it escapes it. If I didn't have that backslash, what bad thing would happen? Yeah, so it would interpret that forward slash as if it's the forward slash here, sort of the thing separate thing to be replaced on the one hand from the thing with which to replace it. Well, I think Ottawa would be happy with that utterance. Here we have these, we have a need to separate the thing to replace by the thing with which to replace it, but we need to be able to handle these backslash which occur in this sort of form. So we do a backslash this, and it says, hey, don't treat this as if it's a, as if it's a delimiter. Just treat it as a character. Okay. So that's great. And here we have, what is this? So here we have the first thing. So this is the month. Here the second thing. This is the day. Okay. And then we have the third thing, and then the fourth thing. Oh, okay, that's interesting. Okay, right. So I did this so it would handle, what is this thing? If it occurs, what is this? Yeah, the first two digits of a 4-digit year. So, for example, this might be 1999 or something like that. So the idea is we throw this away if it occurs. Now, it might or might not occur. That's what the question mark means. And the point is we want these last two digits. If this doesn't occur, great. This \3 will be empty. If it does occur, well, then we'll just throw it away because what we want is the last two digits of the year. Okay? So that's an example expression. Here's a shed script that might map month, day, year into two-digit month days. And so here, we're able to handle statements of months as written out longhand. So January through December, for example. 01, we first map those to 01 to 012, and then we handle it in this format above. So here we can handle months as specified in written terms by mapping them first to numbers, and then we just use this pattern we created above. So this is taking advantage of the fact that these lines all occur before we get to this pattern down here. So all the months have been cleared up, cleaned up, canonicalized, normalized. We use different terms for the same idea prior to to doing this mapping down at the bottom, to doing this mapping in terms of number digits for month, day, year. Does that make sense? This is a sed script. Okay? People comfortable with that? Great. Okay, so here might be another example. So we want to map the dash character into a sequence indicating not available, for example. Or here we want to turn parenthesized expressions that contain digits, potentially with a decimal point, into a negative of that expression. Where would we use that? Where is a parenthesized, like where does parenthesized 100 mean minus 100? Yeah, income statements, yeah. So in certain financial statements, this is the convention. So this will allow us to do that. Note the escape applied to the open paren, close paren. That letting us know, hey, we're not just interested in doing grouping like we are at this point or this point. We're interested in this point, the inner point, but we're interested in matching an actual open parentheses, an actual closed parentheses, so we have to escape it. We have to say, hey, take this as the actual character. Don't treat it as root. Okay? And then we're going to replace it by whatever. People comfortable with that backslash in the context of replacement? Okay. So if you folks aren't saying nifty or your generation's equivalent of that, then I think you should think more broadly, because this can save you a huge amount of effort. Could you do all these things manually by opening up in a text editor through Control-H, replacing this by this? Yes. But this is just so much faster. You can just automate it. Every time you get a text file in this format, a file of a financial statement or whatever for each successive month, you just run it through the, get it output, and you can buy it. Think about applying your skills in computer science more broadly when you have tasks to undertake, even if they're not computer science tasks. It can be very powerful. Have you ever thought about using a makefile, for example, to prepare certain commonly needed files? So if you're running a small business, every month you need to do the accounting. It will take in statements like this. It will run through sed and output things like that. And it will put it into LaTeX. It will produce a nicely formatted report. Things like make aren't limited to doing compiles. Things like sed aren't limited to processing source code files. They are tools to help us in all areas of life. And sed, I hope, will be your friend, just as it's mine, for the balance of your career. Okay? That's a large statement. For at least for many, many years hence, we'll be in the same shared good company. Okay? One thing I will say, and this gets us right into our next topic, ladies and gentlemen, concerns the issue of debugging. Putting together regular expressions enjoy the many virtues to recommend them, including the virtue of brevity, succinctness, if I could use a less loquacious term. And they offer a great deal of power in a very compact form. But when you build them up into complex forms, they can become quite confusing. Now, sed helps manage this by allowing us to specify different lines. We don't have to pack it all into a single line. We don't have to use a single line to do all of the mapping at once. We can actually have successive lines. And that's actually quite powerful. So, it's quite nice. Perhaps even slick. But it is notable that you will find yourself sometimes frustrated by regular expressions. there's many reasons that it may not work in just the way that you intended. And this will get us thinking about some of the causes for faults in programs. This is the programming fault. And there's often a little bit of debugging part. There was with me. When I was creating the final lab 11, that first thing, I was bumping up against things when I was doing it. And some of those things, in my case, a big set of things was just dealing with sed's normal syntax. So I switched to extended regular expression syntax with -r, and I was a much happier camper. So sometimes you use a period, or you use a begin paren. You think it means one thing, and it's interpreting it another way, and you have to realize, oh, that's okay. Speak to sed, it is this weird dialect, and so we have to speak with it sometimes, phrase that in a different way. Okay? So sometimes it's based on a misunderstanding of what this term means. You have the intention that's very clear, but characterizing that intention in a way that sed will understand it in its kind of little lingo is challenging. That's one set of issues. Another set of issues, regular expressions can be kind of complex. And there's an emergent behavior term, some people will come for 394 next term if you take it. There's an emergent behavior where they may surprise us. We'll see behavior coming out of this regular expression we wouldn't have anticipated, but it's a logical consequence of what we've described. It's unexpected. We overlook the fact that it will do this weird thing for certain cases. And we think it's a bug in its understanding of what we intended it to do. But it's in fact doing exactly what we told it to do. It's just bringing it out in a consistent fashion. Our minds were not consistent in thinking it through. And so there we have to change our regular expression, not because it's misphrased for sed to understand it, but because it's logically inconsistent with what we really need it to do, the requirements. So there's debugging, in short. There's debugging getting to know sed's lingo, and then there's debugging having to do with just thinking through what does this regular expression mean. When you're pursuing that thinking, ladies and gentlemen, it's often a challenging task. And if you just pound at it, and you just keep on modifying and tweaking a regular expression, you'll be missing opportunities. It's much better, ladies and gentlemen, to take your expression that you've been building up, make a copy of it. First of all, think about simplifying it, focusing on just the thing that seems to be going wrong, and ripping out pieces that you don't think were affecting it, to see if you can get it to really so that you can reduce it to a point where you really understand exactly what's going on. And of course, in the meantime, you're giving it some trial input. You are not slaves to the example file that I've provided to you as part of Lab 11. You will need to have your sed scripts work properly on that file. However, you should be testing your sed scripts with all sorts of little inputs besides that to make sure it works fine. Make sure your understanding is right. So, when you have the sed script that's not cooperating, give it some things other than the file I've given you. Give it some small little test cases so that you can develop an intuition for what it's doing. And don't be hesitant to make a copy of it and start ripping things out of it until you get to the heart of the matter, what's going wrong. Okay? And then, based on that understanding, you can take that understanding back to your full file and your full script and modify it in a surgical fashion. Okay? So, you will find frustrations. And this first problem on the web is simultaneously about sed and replacing regular expression and about debugging. They are not solved. The things we learned about debugging in the closing minutes this time and in our next session will apply to that exercise. Okay? So those are some comments on sed. And that brings us in. It segues us in.